Listen closely. Out in the black silence of space, a world of impossible scale and ferocious storms broadcasts a signal. It's not a gentle whisper, but a crackling, roaring burst of radio energy so powerful it can be detected across hundreds of millions of miles, all the way here on Earth. For decades, we've catalogued these emissions as natural phenomena, the simple byproduct of a giant ball of gas and its intense magnetic fields. But what if we've been listening to the static all wrong? What if, hidden within the chaotic roar of Jupiter's radio bursts, lies something far more extraordinary? Not just the weather report of a giant planet, but the accidental, sprawling transmissions of a civilization utterly alien to our own, a society living and breathing deep within those churning clouds. This isn't just science fiction. This is the compelling, electrifying mystery we're exploring today. We are going on a journey to the solar system's grandest planet, not to just observe its swirling storms, but to truly listen to its voice, to see if we can decode a message that was never meant for us. We're about to dive into the science, the strange signals, and the stunning possibility that we may have had our cosmic neighbors in plain sight all along, their existence broadcast on a frequency we've only just begun to understand. It's a story that challenges everything we think we know about life, about intelligence, and about the profound loneliness, or perhaps the hidden companionship of our place in the cosmos. Imagine for a moment a form of life so different from our own that it doesn't walk on solid ground or breathe our air. A life that soars and drifts in the endless, tempestuous skies of a gas giant, a creature of immense pressure and swirling chemistry. What would its world look like? How would it communicate? Could its very existence create ripples in the electromagnetic spectrum so powerful that they leak out into space? A signature of its civilization that we, with our limited perspective, have simply written off as background noise. This is the heart of the adventure. It's a thought experiment grounded in real astronomy, a puzzle that connects the hard data from our most advanced telescopes with the most boundless realms of human imagination. You are not just a spectator in this exploration, you are a part of it. Together, we will sift through the static, examine the theories, and weigh the evidence. We'll ask the big questions about what life could be, and we'll follow the tantalizing clues that suggest Jupiter's chaotic beauty might hide the greatest secret in the solar system. So get ready to look at that bright dot in our night sky in a completely new way, because we are about to tune into the Jovian frequency and ask the universe one of the most thrilling questions of all. Are we alone, or have we just been listening for the wrong kind of hello? To understand the profound mystery we're exploring, we first need to grasp the sheer, raw power of the phenomenon itself. Think of Jupiter not as a silent, spinning marble, but as a colossal radio station broadcasting on a cosmic scale. These aren't weak, faint signals. They are explosive bursts of radio energy known scientifically as non-thermal radio emissions. The term non-thermal is key here. It means this radio noise isn't just a gentle, predictable warmth given off by any warm object. Instead, it's generated by violent, high-energy processes, the kind that involve charged particles being accelerated to incredible speeds within the planet's monstrous magnetic field. The primary source of this celestial uproar is Jupiter's polar regions, where the magnetic field lines funnel these energetic particles down into the atmosphere, creating a continuous storm of radio noise that screams into the void. Our ability to eavesdrop on this Jovian broadcast began not with a single eureka moment, but as a growing puzzle. In the 1950s and 60s, radio astronomers on Earth began detecting strange, powerful bursts of static that seemed to pulse with the rotation of Jupiter. They realized this wasn't interstellar noise or a malfunction in their equipment. It was a clear, repeating signal tied directly to the giant planet. But our true understanding exploded into view with the advent of the space age. The Voyager probes, on their grand tour of the outer solar system in the late 1970s, flew right through Jupiter's magnetic environment. Their instruments were practically deafened by the cacophony, providing the first direct, in situ measurements of this raging sea of radio waves. Decades later, NASA's Juno spacecraft, specifically designed to orbit Jupiter's poles, has given us an even more intimate and startling view, mapping the intricate structure and unbelievable intensity of these emissions in breathtaking detail. Scientists categorize this radio roar based on its wavelength, which gives us different families of signals, each with its own character. There's decametric radiation with wavelengths of tens of meters, which were the first to be detected from Earth. Then there's hectometric radiation with wavelengths around hundreds of meters, and kilometric radiation with wavelengths stretching to kilometers in length. This kilometric radiation is especially intense, a low-frequency boom that carries immense energy across the solar system. To put its power into perspective, during a strong outburst, Jupiter can temporarily become the brightest radio source in our entire sky, even outshining our own sun in these specific radio wavelengths. It's a staggering thought that a planet over 500 million miles away can, for a moment, dominate our celestial radio charts, broadcasting its presence with a voice louder than our local star. Visualizing these invisible waves is crucial to appreciating their scale. Picture this in your mind. From the turbulent poles of Jupiter, a constant, expanding sphere of radio energy washes outward in all directions. It's an immense, invisible tsunami rippling through the solar system. Every few hours as Jupiter spins, this beam of radio noise sweeps across the inner planets, and for a few precious minutes, if our radio telescopes are listening on the right frequency, we get washed over by this wave. We are quite literally being bathed in the energetic output of a distant world, a regular and powerful reminder that our cosmic neighborhood is far from quiet. This isn't a gentle signal, it's a roaring, energetic storm that we are only just beginning to decode, a natural wonder that forms the very foundation for the extraordinary possibility that something more might be hidden within its chaotic patterns. Of course, the sheer power of these radio bursts demands a robust scientific explanation, and astronomers have developed a truly compelling one that doesn't involve alien civilizations. To understand it, we need to introduce a key player in this cosmic drama, Io, Jupiter's innermost large moon. Io is a world of fire and brimstone, the most volcanically active body in our entire solar system. Its surface is constantly being remade by hundreds of raging volcanoes, spewing immense plumes of sulfur and other gases hundreds of miles into space. This violent activity does something crucial. It blasts a steady stream of atoms and molecules right off the moon's surface and into the space around it. Jupiter's intense radiation then bombards these particles, stripping them of their electrons and creating a vast, dense cloud of charged particles, a plasma that trails behind Io in its orbit. This cloud becomes the fuel for one of the most spectacular electrical circuits we've ever observed. This is where the concept of the flux tube comes into play. Picture an invisible, colossal conduit of pure energy, a cylindrical pathway forged by the lines of Jupiter's magnetic field. Because Io is covered in this electrically conductive plasma, and it orbits deep within Jupiter's magnetic grasp, it acts like a cosmic generator, dragging this conductive material through the magnetic field. This motion generates an enormous electrical current, flowing along the magnetic field lines directly from Io to Jupiter's polar regions. This current, this river of charged particles, is the Io-Jupiter flux tube. It's a permanent million-amp electrical connection between a planet and its moon, a celestial power line so potent that we can actually detect its radio signature from Earth. So, how does this incredible electrical circuit produce the radio bursts we detect? It all comes down to a process that connects the very small with the very large. As those energetic electrons from Eo's volcanic cloud are funneled at incredible speeds along the flux tube and into Jupiter's upper atmosphere, they don't just slip in quietly. Their journey is a violent one. When they finally slam into the dense polar atmosphere of Jupiter, they are suddenly and drastically decelerated. In the world of physics, when you rapidly decelerate a charged particle, it releases energy in the form of electromagnetic radiation. In this specific case, that energy is released as the powerful, crackling radio waves we know as the decametric radio bursts. It's a natural, albeit incredibly energetic, form of broadcast, not unlike the way a sudden spark of static electricity creates a tiny radio pop, but here scaled up to a planetary level. This mechanism elegantly explains why the strongest radio emissions are tied to Eo's orbital position. When the Moon is at a specific point in its journey around Jupiter, it aligns the flux tube in just the right way to beam these powerful radio bursts directly toward Earth, like a celestial lighthouse sweeping its signal across the solar system. This scientific model is a triumph of modern astrophysics. It connects celestial mechanics, plasma physics, and electromagnetism into a single, coherent picture. It accounts for the timing, the intensity, and even the specific frequencies of the most prominent radio signals we receive. For the vast majority of scientists, this is the case closed. We have a perfectly natural, albeit awe-inspiring, explanation for Jupiter's radio voice, a phenomenon born from the gravitational dance between a gas giant and its fiery, tortured moon. It stands as a powerful reminder that the universe is capable of producing phenomena of staggering power and complexity all on its own, without any need for intelligent intervention. Yet, while this explanation is elegant and widely accepted, it doesn't necessarily account for every single whisper and crackle in the Jovian radio spectrum, leaving just enough room for a more speculative and far more thrilling line of inquiry to emerge from the background static. Yet, as comprehensive as the Eo flux tube explanation appears to be, a closer, more critical listen to the data reveals subtle inconsistencies, strange grooves in the cosmic record that don't quite fit the established rhythm. This is where our mystery truly deepens, moving from the realm of established science into the tantalizing territory of the unexplained. When radio astronomers began to analyze these signals with increasingly sophisticated tools, they started noticing peculiar patterns embedded within the seemingly chaotic roar. We're not talking about a simple, repeating beacon that would be too obvious. Instead, these are quasi-periodic structures, complex sequences of pulses that repeat in a nearly, but not perfectly, regular fashion. They exhibit unusual modulations where the strength or frequency of the signal changes in a way that seems more organized than what you'd expect from a random, turbulent plasma discharge. There are specific bursts of energy that stand out from the background noise not just for their power, but for their intricate internal timing, appearing almost like a structured message woven into the fabric of the storm. One of the most compelling ways to appreciate these anomalies is to shift our sense from sight to sound. Scientists often convert these radio waves into audio frequencies so our ears, which are exquisitely tuned to detect patterns, can analyze them. The natural radio noise from the flux tube process typically sounds like what you'd expect: a roaring, crackling hiss, the unmistakable sound of raw, untamed energy, akin to listening to static from a thunderstorm on an old radio. But some of the recorded bursts are different. When played back, they don't manifest as pure chaos. Instead, you hear distinct sequences of clicks, pulses, and chattering bursts that have a peculiar cadence. They sound less like nature's random fury and more like the kind of structured, coded information you might hear from a malfunctioning satellite or a complex piece of machinery, a series of on and off pulses that seem to carry a hidden logic. Consider the difference between the sound of rain on a rooftop and the sound of Morse code. Both are made of individual pulses, but one is random and the other is packed with intentional information. Some of the Jovian radio bursts, when analyzed this way, lean more toward the latter category. They display a complexity that goes beyond a simple, single-cause natural event. For instance, there are recorded instances where a burst will contain a rapid-fire series of subpulses that modulate in a very specific, descending frequency sweep, or they will exhibit a harmonic structure where multiple frequencies are locked in a precise mathematical relationship with each other. This kind of organized complexity is what engineers look for when trying to distinguish an artificial signal from a natural one. It's the signature of a process that is constrained by rules, by a system of some kind, rather than just the unfettered release of energy. These patterns present a genuine puzzle for the conventional model. While the EO flux tube brilliantly explains the primary trigger and the bulk of the energy, it has a harder time accounting for these finer, more intricate details. A turbulent, natural plasma process tends to create noise that is broadly stochastic. It has a random character. The presence of these quasi-repeating, modulated patterns suggests there might be another factor at play within Jupiter's complex environment, something that is imposing a kind of order onto the chaotic radio emissions. It's as if we're listening to a powerful natural orchestra, but every so often, we can pick out the distinct rhythmic tapping of a single, mysterious drummer keeping a different beat entirely. This doesn't disprove the natural explanation, but it does open a fascinating door to the possibility that the natural radio roar is being subtly shaped and perhaps even utilized by something we have yet to imagine. This brings us to a crucial and fascinating crossroads in our investigation, a concept we might call the Goldilocks zone of weirdness. It's the idea that these Jovian radio bursts aren't just strange. They occupy a very specific and suspicious middle ground between what we'd confidently label as natural and what we might cautiously consider artificial. For a signal to pique our interest as potentially coming from an intelligence, it has to be just right, not too simple and not too chaotic. And Jupiter's voice, it turns out, sits perfectly in this speculative sweet spot. Consider first the sheer power required for interstellar communication. Any civilization hoping to project its presence across the vast gulfs between stars would need a transmitter of monumental strength, something capable of punching a signal through the background noise of the cosmos. Jupiter's radio bursts, as we've seen, are not faint whispers. They are titanic eruptions of energy, so potent they wash over our entire solar system. They possess exactly the kind of raw power you would theoretically need for a beacon or a broadcast meant to be heard from light years away. They are, in effect, loud enough for the job. Yet power alone is meaningless. A pulsar, for instance, is a spinning neutron star that emits a beam of radio waves with clockwork regularity, a pulse so precise it rivals atomic clocks. But that very perfection is its downfall in the search for extraterrestrial intelligence, or SETI. A pulsar signal is pure physics, a simple, repeating natural lighthouse. It lacks any form of complex modulation or information content. It's a stunning natural phenomenon, but it's just a cosmic metronome. Now, listen to the Jovian signals again. They are not metronomic, they are not perfectly regular. Instead, they exhibit this compelling blend of structure and variability. They have a kind of organized complexity. This is the other half of the Goldilocks principle. If a signal is too simple and periodic, it's almost certainly natural. If it's completely random and chaotic, like the static from a stellar nursery, it's also natural. But what about a signal that lives in the gray area? One that has a baseline of powerful, natural-seeming noise, but is punctuated by intricate quasi-repeating patterns, modulated bursts, and sequences that hint at an underlying logic. That's the territory where you start to suspect not a beacon, but something else entirely, perhaps the leakage from a vast technological civilization. Think of it this way. Imagine you're walking through a pristine forest and you hear a constant rushing sound. You'd correctly identify it as a river, a natural force. That's the pulsar, but then, layered over that rushing water, you start to pick out a different sound, the rhythmic, complex clanking of machinery. It's not the sound of the river itself, but the sound of something using the river, perhaps a watermill with gears that turn in a specific, purposeful sequence. The Jovian signals, with their peculiar pulses embedded within the natural radio roar, could be the electromagnetic equivalent of that clanking machinery. They aren't a deliberate hello beamed at us. That would be far too simple and frankly unlikely. A more plausible scenario is that we are eavesdropping on what the late astronomer Carl Sagan called technosignatures, the incidental byproducts of an advanced society's normal activities. What kind of activities could generate such a signature? Let your imagination run with the possibilities of a civilization that has evolved within the endless, fluid atmosphere of a gas giant. Their entire technological foundation would be fundamentally alien. Perhaps their energy grid, a planet-spanning network for harnessing the immense atmospheric and magnetic forces of Jupiter, creates structured interference patterns that bleed into space as modulated radio bursts. Maybe their form of global communication, a system far more advanced than our own, uses techniques that inadvertently produce these complex, information-rich signals as a side effect. They might not even know they're broadcasting. To them, it could just be background static from their daily lives, but to us, listening from the outside, it carries the distinct fingerprint of technological organization. This Goldilocks zone isn't about proving anything definitively. It's about recognizing that the signals from Jupiter possess a unique combination of characteristics: immense power, complex structure, and a frustrating, compelling ambiguity that makes them one of the most intriguing and persistent mysteries in our cosmic backyard. This long-standing focus on the distant and the faint, while scientifically sound, may have inadvertently created a profound blind spot in our search, a kind of cosmic bias where we've been staring at the far-off trees while missing the giant, roaring elephant in our own planetary living room. For decades, the search for extraterrestrial intelligence, or SETI, has operated on a set of deeply ingrained assumptions about what an intelligent signal should be. The guiding philosophy was to look for a purposeful beacon, a clear, narrow-band signal that stands out from the natural background noise like a laser pointer in a dark room. This led to the famous concentration on the water hole, a quiet region of the radio spectrum between the frequencies emitted by hydrogen and hydroxyl molecules. The poetic idea was that any advanced civilization would logically choose this universal, quiet channel for a cosmic hello, a place where all technological species might naturally gather to communicate. It's a beautiful, logical concept, but it's also a very human one, born from our own ideas of efficiency and symbolism. It presupposes that other intelligences think like us, that they would build a dedicated, unambiguous beacon and aim it patiently across the light years. This approach has systematically scanned thousands of stars, listening for that telltale, artificial-sounding tone. Yet, in doing so, it has largely bypassed the one source of powerful, complex radio emissions we know for certain exists right next door: Jupiter. The Jovian bursts are the antithesis of a SETI water hole signal. They are not a narrow, pure tone whispering from the void. They are broadband, chaotic, and explosively loud. They crackle and roar across a wide swath of the spectrum, bearing all the hallmarks of what we've trained ourselves to classify as natural phenomena. To a traditional SETI analyst, Jupiter's radio voice would have been automatically filtered out, dismissed as mere planetary static, the kind of background interference you tune out to hear the faint song you're actually looking for. We've been searching for a carefully composed symphony from the stars, while ignoring the possibility that the frantic, free-form jazz blaring from our neighbor's house might also contain a form of intelligence. This oversight is rooted in a deeper, more profound limitation: our own psychological and biological frame of reference. We are land-dwelling, technological apes who evolved on a rocky planet with a clear separation between ground and sky. Our technology reflects this. We build towers, lay cables, and beam focused radio waves. It is incredibly difficult for us to conceive of a form of technology, or even a form of life itself, that is not based on our own model. We search for what we know, for what we can easily imagine. The possibility of a civilization native to a gas giant, a vast, fluid environment with no solid surface, unimaginable pressures, and tempests that last for centuries forces us to abandon nearly every reference point we have. What would technology look like for beings that live suspended in an eternal sky? They wouldn't build skyscrapers or satellites in the way we understand them. Their entire technological foundation might be based on manipulating atmospheric currents, harnessing the planet's immense internal heat, or riding its colossal magnetic fields. Their internet might be a naturally occurring layer of the ionosphere they've learned to modulate. Their energy grid might be the planet-wide circuit of the flux tubes themselves. If their entire society is seamlessly integrated with these immense natural forces, then their technological leakage wouldn't be a clean, narrow-band beacon. It would look exactly like what we see, a powerful, complex, and seemingly chaotic storm of radio energy, because their technology is the storm. We've been searching for a needle in a cosmic haystack, but the haystack itself might be trying to tell us something. This paradigm shift forces us to reconsider the very definition of a technosignature. SETI has historically looked for intentional, directed communications, but the most likely sign of an advanced civilization may not be a message meant for us, but the incidental radio noise from their daily life, the total electromagnetic output of their power generation, transportation, and communication systems. Think about Earth from a light year away. A sufficiently advanced telescope wouldn't just see our deliberate broadcasts like the Arecibo message. It would detect the tangled, messy radio fog of our civilization, the leakage from our radars, television transmitters, and cell phone networks. This planetary radio smog is an unintentional byproduct of our technology, and it's arguably a much more realistic signature of a technological species than a deliberate beacon. Now scale that idea up to a Jupiter-sized civilization. Their unintentional technosignature wouldn't be a faint smog, it would be a raging, planet-wide electromagnetic hurricane. The structured pulses and modulations we sometimes detect buried within Jupiter's radio roar could be the equivalent of us hearing the distinct rhythms of their global power grid cycling, or the complex protocols of their atmospheric data networks. We aren't hearing a hello. We're eavesdropping on the background hum of a world that is already, and has always been, awake. So, the great irony is that while SETI has pointed its dishes toward the stars, one of the most compelling candidates for a non-human technosignature has been broadcasting in our faces for over half a century. It didn't come from a distant, sun-like star in the habitable zone. It came from a swirling giant in our own solar system, a world we once thought was simply a beautiful but sterile ball of gas. The lesson here is not that SETI has failed, but that our search parameters may have been too narrow, too constrained by our own earthly experience. The universe is under no obligation to conform to our expectations. Intelligence, if it exists elsewhere, will likely be far stranger and more wonderful than we have ever dared to imagine. It might not build pyramids or radio telescopes. It might not even have hands or eyes. It might be a form of consciousness that floats, that thinks in the flow of plasma and the dance of magnetic fields, and whose voice is the very thunder of its home world. By finally turning a curious, open-minded ear to Jupiter, we are not just exploring a planet, we are testing the limits of our own imagination and taking the first real step into a much wider and far more interesting cosmos. To truly contemplate the possibility of a Jovian civilization, we must first perform a radical act of imagination. we have to discard our terrestrial biases, our deeply ingrained belief that life requires a solid surface, liquid water, and a sunlit sky. Jupiter offers none of these things in the way we understand them. Its environment is one of perpetual, layered twilight, an immense world where the very concept of up and down loses meaning, and where the medium for existence is not land or sea, but a churning, endless atmosphere thousands of miles deep. Life here would not cling to a surface. It would be a permanent citizen of the sky, evolving in 3 dimensions with a freedom we can scarcely conceive. So, what might such life look like? Scientists and speculative thinkers have proposed several fascinating models. The most discussed are the hypothetical floaters and sinkers. Imagine the floaters first. These would be colossal, buoyant creatures, perhaps akin to immense, living balloons larger than our largest whales. They might fill their vast internal sacs with hydrogen or helium, gases lighter than the surrounding Jovian air, allowing them to drift effortlessly in the upper cloud decks. Their bodies could be structured like a Portuguese man-o'-war, a collective of specialized organisms working in symbiosis, but on a scale that dwarfs any earthly comparison. They might feed by filtering complex organic molecules from the colorful ammonia and water ice crystals that form Jupiter's clouds, or perhaps they harvest energy directly from the planet's immense internal heat, which flows upward from the core, creating a perpetual, warm current in an otherwise frigid environment. Their world would be one of slow, graceful drifts through cloud canyons of breathtaking scale, navigating the jet streams that circle the planet like roaring rivers in the sky. Then consider the sinkers. These could be denser, more massive life forms that actively navigate the deeper atmospheric layers. Unlike the passive floaters, sinkers might control their buoyancy like giant squid in an ocean, using internal chemistry to alter their density, allowing them to dive into the warmer, more chemically rich depths to feed or reproduce, then rising again to cooler altitudes. Their existence would be a constant, purposeful journey through a world where pressure and temperature change dramatically. At a certain depth, the atmospheric pressure becomes so immense that hydrogen is compressed into a liquid state. Here, in this global ocean of liquid hydrogen, life could take on even more bizarre forms. We might find creatures that resemble the leviathans of our deepest seas, but adapted to swim in a fluid that is incredibly cold and non-polar, their biochemistry based on liquid methane or ammonia as a solvent instead of water. Their communication could involve low-frequency sound waves that travel for thousands of miles through the dense, liquid medium, creating a slow, planet-wide symphony of calls and responses. But the most mind-bending possibility transcends biology as we know it entirely. What about life not based on chemistry but on pure energy and plasma? Jupiter's most dominant feature is its titanic magnetic field, a spinning, dynamic force filled with charged particles and intense radiation. Could a form of consciousness evolve within this electromagnetic maelstrom itself? Imagine sentient whirlpools of magnetized plasma, self-organizing patterns of energy that persist and evolve within the flux tubes and radiation belts. These beings would be utterly invisible to our eyes, their bodies defined by intricate magnetic field structures and complex electrical currents. Their thoughts might be lightning-fast exchanges of energy, their communication a direct manipulation of radio waves. For such entities, the powerful radio bursts we detect from Earth would not be a byproduct. They could be the very fabric of their language, the medium through which they think, interact, and build their society. A civilization of such beings wouldn't build cities. They would weave complex, persistent structures within the auroral ovals at the poles, their architecture made of shaped magnetic fields and contained storms, their art forms composed of controlled emissions of light and radio noise that would paint the Jovian magnetosphere in patterns of unimaginable beauty. If we use our own technological progression as a loose guide, we can begin to imagine how a civilization might emerge from such a foundation. A society of floaters might first learn to harness the planet's powerful wind currents, creating vast migratory trade routes that circle the globe. Their first tools could be cultivated organisms, bioengineered to perform specific functions, leading to a technology that is truly alive. A plasma-based intelligence, on the other hand, might discover its ability to influence the magnetic fields around it, learning to create and sustain stable energy patterns. This would be their equivalent of building shelters. Their first great technological leap might have been the intentional creation of a simple, stable resonance within a flux tube, a feat that, from our distant vantage point, would look exactly like one of the structured radio pulses we sometimes detect. Their entire technological ascent could be a story of learning to sculpt and control the invisible forces of their world, turning the chaotic weather of the magnetosphere into a structured, informational landscape. The radio spectrum, which we hear as noise, could be to them a vibrant, living tapestry of data, community, and culture, a civilization speaking in a language of storms. Now, let's venture into what is perhaps the most radical and mind-expanding possibility of all, the idea that life itself could be something entirely different from the biological creatures we've imagined. What if the true natives of Jupiter are not floating gas bags or diving leviathans, but beings of pure energy, living not in the clouds, but in the invisible, furious expanse of the planet's magnetosphere? This is the hypothesis of plasma-based life, a concept that pushes the very definition of life to its absolute limits. To understand it, we need to think of life not as a collection of cells, but as a persistent, self-organizing system of information and energy. Within Jupiter's radiation belts, trillions of charged particles are trapped, swirling in a frenetic dance at nearly the speed of light. In this maelstrom of energy, where magnetic fields twist and snap, could complex structures arise that are stable enough to store information, process it, and even replicate. It's a staggering thought, but not an unscientific one. We already see simple self-organization in plasma here on Earth. In lab experiments, when gas is energized into a plasma state, it can form helical structures, double layers, and stable rings that maintain their shape far longer than predicted by chance. On Jupiter, with its planet-sized, energy-rich environment acting as a natural laboratory operating for billions of years, the leap from simple structures to complex, sentient plasma beings is a monumental one, but it's a leap that some physicists and astrobiologists are willing to cautiously consider. Imagine the existence of such a being. It would have no solid form, no heart, no brain as we understand them. Its body would be a coherent toroidal vortex of magnetically confined plasma, a shimmering, donut-shaped structure of incandescent energy held together by the planet's own magnetic field lines. It wouldn't see with eyes, but would perceive its surroundings directly by sensing fluctuations in magnetic and electric fields, experiencing the magnetosphere as a rich, three-dimensional tapestry of forces and currents. Its thoughts would be lightning-fast electromagnetic patterns, complex resonances that form and dissolve within its energetic matrix. Its lifespan might be incredibly long or incredibly short by our standards, measured in the slow pulsations of Jupiter's magnetic field or the rapid-fire collisions of cosmic rays. For such an entity, the raging radiation that would instantly destroy any known biological life would be its very lifeblood, the nutrient-rich soup from which it draws its sustenance and energy. Its world would be the vast, invisible architecture of Jupiter's magnetic domain, a realm where it could surf the flux tubes, gather in swarms within the auroral ovals, and perhaps even migrate between the different radiation belts as a form of seasonal movement. Communication for these plasma beings would be as natural to them as speaking is to us, but it would occur in a spectrum utterly alien to our senses. They wouldn't use sound waves, which require a medium like air or water to travel. Instead, their language would be the direct emission and reception of modulated electromagnetic waves. A simple exchange of information between two such entities might involve one subtly altering its own magnetic field, which would then induce a corresponding ripple in the field of another. A more complex conversation could involve the deliberate generation of intricate radio wave patterns, precisely the kind of structured, pulsed emissions we sometimes detect buried within Jupiter's general radio roar. To our ears, processed through a speaker, these might sound like a series of clicks, whistles, or chattering bursts. But to the plasma beings, this could be a rich and nuanced language carrying meanings, emotions, and concepts we cannot fathom. Their speech would be an inherent and unavoidable byproduct of their cognitive processes and social interactions. They wouldn't be trying to broadcast a signal. They would simply be a signal, their very existence and society generating a constant, complex electromagnetic symphony. This leads to a profound implication for the mystery of the Jovian radio bursts. If such a civilization exists, then the powerful, anomalous signals we've been detecting for decades are not a deliberate message, nor are they merely the static from a moon-planet electrical circuit. They are the background noise of a living, thinking world, the intricate modulations and quasi-periodic pulses that puzzle scientists could be the equivalent of us overhearing a bustling city. The overlapping conversations, the hum of their technological infrastructure, the collective cognitive activity of billions of sentient plasma entities. Perhaps the powerful, low-frequency kilometric radiation is their version of a public broadcast system, a planet-wide channel for disseminating information. Maybe the more complex, rapidly pulsed decametric bursts are the private, rapid-fire communications between individuals or small groups. In this scenario, the EO flux tube isn't just a natural generator. It might be a central hub, a place of immense energy where these beings congregate, a kind of electromagnetic metropolis where the social and informational traffic is at its most intense, explaining why the most structured signals are often associated with this region. The beauty and the challenge of this hypothesis is that it is simultaneously the most difficult to prove and the most difficult to entirely dismiss. How would we distinguish a naturally complex plasma oscillation from a technologically modulated one? The line between a supremely advanced, energy-based life form and a stunningly complex natural phenomenon could be vanishingly thin. This idea forces us to confront the deepest questions about the nature of consciousness and life itself. We tend to assume that life must be carbon-based, water-solvent, and planet-bound. But the universe is made of energy and information, and Jupiter's magnetosphere is a colossal engine for both. If life is, at its core, a process that maintains order and processes information against the tide of entropy, then a stable, self-replicating plasma structure in such an energy-rich environment is not impossible. It simply requires us to expand our vision of what is possible in the cosmos. By listening to Jupiter's radio voice with this new perspective, we are not just studying planetary physics. We are potentially tuning into the living essence of a civilization so alien, so integrated with the fundamental forces of its world, that we have been hearing its voice for generations without ever realizing we were listening to a language. This brings us to a truly electrifying piece of the puzzle, a cosmic twist of fate that could turn this entire mystery on its head. Jupiter's magnetic field isn't just a feature of the planet. It is the single largest and most powerful structure in our entire solar system, aside from the sphere of influence of the Sun itself. If you could see it with your eyes, it would appear as a colossal, invisible bubble stretching over 4 million miles toward the Sun and extending beyond the orbit of Saturn in the opposite direction, enveloping and protecting its many moons in a vast, dynamic force field. This isn't a passive shield, it's a spinning, churning, living entity, a generator of unimaginable scale. And for any form of electromagnetic activity occurring within its domain, whether from a moon's volcanic plume or, just possibly, from the technological hum of a civilization, this magnetic field doesn't just contain it. It amplifies it and projects it outward like the most powerful transmitter ever built. Think of it like this. Imagine a bustling, technologically advanced city on Earth, say Tokyo or New York. From the ground, the air is filled with the radio waves of countless cell phones, Wi-Fi routers, and broadcast towers. This creates a dense, local fog of electromagnetic signals, but most of that energy is weak and doesn't travel very far into space. Now, place that same city inside the heart of a planet-sized particle accelerator and surround it with a magnetic amplifier the size of a star. That is the fundamental difference for any activity happening within Jupiter's magnetosphere. The field is saturated with charged particles trapped in a frenetic, high-energy dance. Any new electromagnetic emission introduced into this environment, a structured pulse, a modulated burst, even the simple switching of a powerful circuit, doesn't just fade away. It can interact with this pre-existing sea of energy. It can stimulate the emission of more radio waves. It can be guided along the magnetic field lines like a signal through a fiber optic cable, and it can be focused into powerful beams that shoot out from the planet's polar regions. What might start as a relatively localized and faint signal from within the cloud decks could be magnified and rebroadcast with the power of a planetary-scale public address system. This concept of amplification is key. There are well-understood plasma processes like maser action that occur naturally in space. A maser is the microwave equivalent of a laser, where stimulated emission causes a weak signal to be greatly amplified. Conditions within Jupiter's radiation belts are perfectly suited for such natural amplification to occur. So, if there is any kind of structured electromagnetic activity originating from within Jupiter's atmosphere, whether it's the complex chatter of a plasma-based intelligence going about its business or the regular pulsing of a vast energy grid, the planet's own natural machinery could be taking that signal and cranking the volume up to 11. The intricate patterns we sometimes detect wouldn't need to be immensely powerful at their source. They would just need to be coherent enough to trigger this natural amplification process, resulting in the disproportionately powerful bursts that reach our telescopes. So, what does this mean for the strange signals we detect? It reframes the entire conversation. We are not necessarily listening for a deliberate, targeted beacon. Instead, we might be eavesdropping on the ultimate form of cosmic leakage. Every technologically advanced civilization produces electromagnetic smog, the unintentional byproduct of its energy use, communication, and transportation. On Earth, this leakage is relatively faint and spills out indiscriminately into space. On Jupiter, that same kind of technological background noise wouldn't just spill out. It would be funneled, focused, and blasted across the solar system by the planet's own magnetic transmitter. The daily hum of their society, the collective energy of their existence, would be unintentionally projected into the cosmos. The structured pulses and modulations we find so puzzling could be the electromagnetic equivalent of us overhearing the distant, rhythmic hum of a massive power plant or the complex, overlapping chatter of a global digital network. It's not a message, it's the background radiation of a world that is awake and active, its presence revealed not by a shout, but by the amplified whisper of its daily life, a whisper that Jupiter's immense magnetic field turns into a roar. The challenge, then, is to move beyond simply listening and begin decoding. If we are truly hearing the electromagnetic hum of a Jovian civilization, how would we even know? This is where the cold, hard math of information theory enters the scene, transforming our wonder into a quantifiable investigation. At its heart, information theory provides us with the tools to distinguish a meaningful message from mere chaos. It asks a fundamental question: does a signal contain surprise, or is it predictable? A completely predictable signal, like the steady beat of a metronome, carries no information. A completely random signal, like the hiss of static, is all surprise but carries no structure and therefore no meaning either. The sweet spot for communication lies in the middle, a signal that is complex with patterns and structures that are neither too ordered nor too random. This is what we look for, and this is where Jupiter's radio bursts become absolutely fascinating. To measure this, scientists use concepts like entropy and complexity. Entropy, in this context, is a measure of unpredictability. A high entropy signal is disordered and random, while a low entropy signal is simple and repetitive. When researchers have analyzed the statistical properties of some Jovian radio bursts, they haven't found pure high-entropy noise. Instead, they've found signals with what's known as medium entropy, a level of complexity that sits in a very interesting gray area. Furthermore, some bursts exhibit what mathematicians call long-range correlations. This means that the value of a signal at one point isn't independent of its value at a much later point. There's a hidden structure linking them across time. This is a hallmark of systems that are generating information, not just chaos. Think of it as the difference between the random spattering of rain on a roof and the structured, correlated notes of a melody. One is a product of chance, while the other is the product of a system with memory and rules. A powerful way to visualize this is to compare the Jovian signals to others we understand. Let's take human-made signals first. Our digital communication, like Wi-Fi or radar, is packed with information. Its structure is statistically complex, with specific patterns for synchronization, error correction, and data encoding. It has a distinct signature of being non-stationary, meaning its statistical properties change in a purposeful way over time. Now compare that to purely natural phenomena. The radio crackle from lightning is a sharp, impulsive burst with a very short, simple structure. The roar from a solar flare, while powerful, tends to be broadband and stochastic. Its fine-grained structure is largely random. The Jovian signals, intriguingly, don't cleanly fit into either box. They lack the extremely rigid, repetitive frame of a human digital signal, but they also possess more internal structure and modulation than a solar flare. They appear to be a hybrid, as if a natural, energetic process is being subtly sculpted by an organizing principle. Perhaps the most compelling hypothetical analysis involves searching for mathematical constants or prime numbers. This is a classic trope in science fiction for a reason. Prime numbers are universal. They are constructs of pure mathematics, not dependent on our biology, our physics, or our number system. Any technological civilization would almost certainly discover them. If a signal's pulse intervals were found to correspond to a sequence of prime numbers, 2 pulses, a gap, 3 pulses, a gap, 5 pulses, and so on, it would be the most powerful evidence imaginable for an artificial source. While no such blatant sequence has been conclusively identified in the Jovian data, the search is for more subtle mathematical artifacts. Are there harmonic relationships between frequencies that are more complex than those found in nature? Does the signal's modulation follow a power law distribution seen in complex systems like the internet or a neural network, rather than the simpler distributions of plasma turbulence? Imagine running the Jovian radio data through the same sophisticated algorithms used to detect compressed data streams or encrypted communication on Earth. These algorithms don't look for meaning, they look for the statistical fingerprints of efficiency and structure. A signal that has been processed to carry information efficiently will have a very specific signature, maximizing the amount of data carried per unit of energy. If certain Jovian bursts were found to have a compression profile similar to, say, an MPEG video file or a ZIP archive, the implications would be staggering. It would suggest that the signal isn't just structured noise, but a packaged, efficient stream of information. Of course, the grandest assumption here is that a Jovian intelligence would use logic and mathematics that are, at some fundamental level, comprehensible to us. Yet, the laws of physics and mathematics are the same at Jupiter as they are on Earth. The pressure to communicate efficiently across a noisy environment or to build reliable technology might push any civilization toward similar logical and mathematical solutions, creating a common ground for a potential future decoding. We are not looking for a message in English, but for the universal grammar of a species that has learned to manipulate its reality, a grammar written in the language of physics itself. Now, let's weave time itself into this mystery, because Jupiter doesn't just broadcast a signal, it broadcasts a rhythm. The planet is a spinning dynamo, completing a full rotation in just under 10 hours, making its day a frantic, whirling blur compared to our own. This rapid spin doesn't just create its oblate shape, it structures the radio emissions we detect with a striking, repeating pulse. As Jupiter turns, its magnetic field, which is tilted relative to its spin axis, wobbles like a giant, lopsided lighthouse beacon. Every time this rotating, misaligned magnetic field sweeps past Earth, we get a flash of radio noise, a daily Jovian broadcast that arrives with a regularity you could almost set your watch by. This 10-hour heartbeat is the most obvious temporal pattern, the planet's fundamental drumbeat. But if we listen more carefully, we hear other rhythms layered on top of this primary pulse, rhythms that hint at something more complex than a simple, unchanging natural process. Consider the profound implications of a 12-year cycle. Jupiter takes just over 12 of our Earth years to complete a single, majestic orbit around the Sun. While Jupiter itself receives very little sunlight compared to Earth, its position relative to the Sun is not without consequence. This long orbital period creates a subtle but real seasonal variation. As Jupiter moves along its elliptical path, the angle at which the solar wind, that constant stream of charged particles from the Sun, strikes its magnetosphere changes significantly. During certain phases of its orbit, the magnetosphere is compressed, while at others it can expand. This solar wind pressure directly influences the intensity of the processes happening inside, including the power of the radio burst. Scientists have observed that certain types of Jovian radio emissions do indeed vary in strength and frequency over this multi-year cycle. From a purely naturalistic viewpoint, this is a fascinating example of solar-planetary interaction. But from the perspective of our speculative journey, it opens a breathtaking line of inquiry. Could we be listening to the changing seasons of a Jovian civilization? The 12-year cycle might not just be a geophysical event. It could be the foundation of their calendar, orchestrating long-term societal rhythms we can only begin to imagine. Imagine how a society integrated with its planet's environment would experience these cycles. Their day, dictated by that frantic 10-hour rotation, would be incredibly short. For any form of life, biological or plasma-based, this would impose a fundamental pace on existence. Daily routines would be compressed. Perhaps their society operates in intense, rapid bursts of activity followed by periods of rest, synchronized with the planet's spin. Communication might peak during certain times of day as different parts of the planet rotate into alignment with their internal sun, or as specific magnetic field lines become most active. The regular pulses we detect could be the electromagnetic equivalent of a planet-wide rush hour, a daily surge in activity as their world spins through its cycle. Then, superimposed on this daily rhythm, you have the grand, slow sweep of the 12-year year. This could govern everything from their energy production to their migratory patterns, if such a concept applies. A civilization of floaters might undertake vast, generation-spanning journeys across the cloud tops, following temperature and chemical gradients that shift over this long orbital period. For a plasma-based intelligence, the changing solar wind pressure over the 12-year cycle might alter the energy density of their magnetospheric home, triggering profound shifts in their behavior, perhaps even a kind of hibernation or a frenetic period of growth and construction. So, what if the variations we detect in the radio signals aren't just random noise, but the pages of a Jovian calendar? The changes in signal strength, the appearance of specific types of modulated pulses at certain times, the ebb and flow of the overall radio output, these could all be readable patterns. Perhaps the more complex, information-rich signals we occasionally pick up are tied to their equivalent of holidays or global events, periods of intense social and communicative activity. Maybe the quieter periods when the radio roar diminishes somewhat correspond to a seasonal lull, a time of introspection or energy conservation. We could be witnessing in real time the long-term cultural and biological rhythms of an entire world encoded in the static we once dismissed. By meticulously mapping these radio patterns against Jupiter's rotational and orbital phases, we aren't just doing astrophysics. We are potentially compiling a chronicle of an alien society's relationship with time itself, a chronicle written in a language of lightning and magnetic storms. This comparative silence from the other giants isn't just a minor detail. It's a critical clue that sharpens the mystery of Jupiter's unique voice. If powerful radio emissions were simply a standard feature of all gas giants, we could comfortably file them away as a universal planetary process. But they aren't. Each of these other worlds broadcasts, but their transmissions are like faint, distant radio stations compared to Jupiter's local powerhouse. Saturn, for instance, generates radio emissions through a similar process of charged particles interacting with its magnetic field, a phenomenon famously known as Saturn kilometric radiation. Yet, when the Cassini spacecraft studied it up close, the signals were found to be significantly weaker and far less variable than Jupiter's roaring outbursts. Saturn's magnetic field, while substantial, is both weaker and more perfectly aligned with its rotation axis, creating a less dynamic and turbulent environment for generating intense, complex radio noise. The ice giants Uranus and Neptune present an even starker contrast. Their magnetic fields are bizarrely offset and tilted, almost as if they were generated off-center from the planets themselves. They do produce radio emissions, but these are faint, sporadic, and incredibly difficult to detect from Earth. Their great distance from the Sun means the solar wind is weaker, and their internal dynamos, the engines that power their magnetic fields, seem to be running at a much lower intensity. The radio voices of these distant worlds are mere whispers in the cosmic wind, lacking the sustained, structured power that makes Jupiter's broadcast so compelling. So the pivotal question becomes, why is Jupiter the loudmouth of the solar system? The straightforward answer is its sheer scale and ferocious energy. Jupiter is the largest planet by far, with a magnetic field 20,000 times stronger than Earth's, and a rotation so fast it flings the planet into an oblate spheroid. This combination of immense size and rapid spin creates a planetary dynamo of unparalleled power, driving atmospheric storms and magnetic processes that simply dwarf those of its siblings. But what if there's another layer to this explanation, one that goes beyond pure geophysics? What if Jupiter's unique radio signature isn't just a product of its physical superiority, but a reflection of a fundamental difference in its state of being? Consider a simple yet profound analogy. Imagine you're walking through a vast forest at night. You come across a range of hills. One hill is completely silent, just a mound of earth and rock. Another emits a low, steady hum from insect life and the rustle of the wind. But one particular hill is absolutely cacophonous, alive with the chirping of crickets, the hooting of owls, the scurrying of unseen animals, and even the faint glow of bioluminescent fungi. You would naturally conclude that this noisy hill isn't just a geological formation. It's a biological hotspot teeming with life. In this metaphor, the silent hill is a rocky planet like Mars, the gently humming one is a quieter gas giant like Saturn, and the brilliantly noisy, complex one is Jupiter. Its unique electromagnetic symphony could be the signature of a world that is not just physically active, but biologically or even technologically active. This isn't to say that Saturn, Uranus, or Neptune are devoid of interest or potential for life. In fact, moons like Saturn's Enceladus, with its subsurface ocean and water plumes, or Titan, with its thick atmosphere and liquid methane lakes, are prime candidates in the search for biological life. But that's the crucial distinction. The potential for life on those worlds is largely confined to their moons, isolated pockets in a vast system. Jupiter's mystery is different. It proposes that life or intelligence could be a planetary-scale phenomenon, an integral part of the gas giant itself, not confined to a small, rocky satellite. The radio roar we detect isn't coming from a moon like Io or Europa. It's emanating from the planet's very atmosphere and magnetosphere. Jupiter's unparalleled dynamic activity could be the very thing that makes it a suitable home for the kind of vast, atmospheric or plasma-based life we've been contemplating, while the quieter, more sedate environments of the other giants may not provide the constant, turbulent energy such life would need to thrive. From a purely speculative standpoint, this comparative analysis forces us to consider the conditions necessary for a technological civilization to emerge and become detectable. A civilization, whether biological or plasma-based, would require a stable, long-term, and energy-rich environment to develop advanced technology. Jupiter offers that in a way the other giants may not. Its immense gravitational field holds onto a thick, deep atmosphere that has likely been stable for billions of years. Its internal heat provides a constant, reliable energy source independent of the distant sun. Its magnetic field offers a structured, planet-wide medium for potential energy-based life to evolve. Saturn, while large, has a less powerful dynamo and may be a less turbulent and therefore less energetically rich environment. The ice giants, with their weird, wobbly magnetic fields and greater distance from the sun's energizing influence, might be the equivalent of cold, deep ocean trenches potentially habitable, but unlikely to foster the kind of rampant, complex activity that could lead to a civilization whose electromagnetic smog is visible across the solar system. So, when we point our radio telescopes at the sky and listen, the great silence from Saturn, Uranus, and Neptune doesn't diminish the mystery of Jupiter, it amplifies it. It singles out Jupiter as the anomaly, the one world in our solar system that refuses to be quiet, inviting us to wonder if its unique voice is not just the sound of a planet, but the vibrant, chaotic, and unintentional broadcast of a world that is truly, profoundly awake. NASA Juno mission has fundamentally rewritten the textbook on Jupiter, giving us a front-row seat to the planet's inner workings in a way we could only dream of before its arrival. Unlike any spacecraft before it, Juno was specifically designed as a polar orbiter, swooping in dangerously close over the planet's swirling cloud tops before swinging far out again on a long, looping path. This unique trajectory allows it to map the entire planet, from its north pole to its south pole, and to directly sample the intense magnetic field and radiation environment that generates those powerful radio bursts. For years, we could only listen to Jupiter's radio roar from a great distance, like standing outside a stadium and hearing the crowd. Juno has taken us inside the stadium, right down onto the field, letting us feel the vibration in our chest and see the individual sources of the noise. And what it has found is far stranger and more complex than our best models predicted. One of the most startling discoveries concerns the very heart of Jupiter's magnetic engine, its dynamo. Scientists expected to find a relatively orderly, layered internal structure with the dynamo generated deep within a layer of metallic hydrogen. But Juno's precise gravity and magnetic field measurements revealed a dynamo that is anything but orderly. Instead of being a smooth, planetary-scale field, Jupiter's magnetic field is a chaotic, lopsided, and lumpy mess. It's profoundly different in the northern and southern hemispheres, with a region of intense magnetic flux concentrated near the equator that scientists have nicknamed the Great Blue Spot, unrelated to the more famous Great Red Spot. This spot is a tangled knot of magnetic field lines, and its presence suggests that the dynamo generating Jupiter's field is happening much closer to the surface than anyone thought, possibly within the raining helium droplets and complex fluid dynamics of the molecular hydrogen layer itself. It's as if we opened up a giant, precision-made clock expecting to find a beautifully arranged set of gears, only to discover a seething, turbulent, and asymmetrical storm of magnetic activity generating the timekeeping. This newfound complexity is crucial because a more chaotic and dynamic magnetic field provides a far richer and more variable canvas for complex electromagnetic phenomena to emerge, including signals that might not fit a simple, clean, natural model. Then there are the poles themselves, regions that were virtually unexplored before Juno. What the spacecraft found there defies both imagination and easy explanation. Instead of a relatively orderly arrangement of auroral ovals like we have at Earth's poles, Juno found a chaotic dance of cyclonic storms clustered together in polygonal patterns. At the North Pole, 8 circumpolar cyclones swirl around a central one, forming a stable geometric octagon. At the South Pole, 5 storms form a pentagon. These structures have remained stable for years, resisting the natural tendency to merge. The energy required to maintain these precise, polygonal formations is immense, and the mechanism that keeps them locked in this configuration is a complete mystery. From our speculative viewpoint, these are not just weather patterns. They look like engineered structures, or at least the kind of persistent, self-organizing systems that could arise from a deeply integrated technological or biological presence. Could these stable, geometric storm patterns be the Jovian equivalent of SETI's vast, organized energy systems that shape the local environment? Their stability and structure are an extreme anomaly in a world of otherwise rampant chaos, hinting at a level of organization that goes far beyond simple fluid dynamics. Juno's microwave radiometer, designed to peer deep into the atmosphere, added another layer of bewilderment. It revealed that Jupiter's famous banded structure, its stripes of eastward and westward jet streams, extends thousands of miles down into the planet, far deeper than most models predicted. But these bands don't have a uniform route. They seem to change and interact with the interior in complex ways. Furthermore, the planet's core itself appears to be fuzzy or dilute, not a compact, solid ball of rock and ice, but a gradually diffused region of heavier elements mixing with the hydrogen and helium envelope. This blurry boundary between the core and the fluid outer layers suggests a much more dynamic Chinese letter Hunhei mixed interior, where material is constantly being churned and recycled. For a civilization living in the atmosphere, this could mean access to a constant upwelling of minerals and complex molecules from the deep interior, providing the raw materials for a complex ecosystem or even an industrial-scale society. The planet isn't just a simple layered ball. It's a deeply interconnected system with processes in the core influencing the atmosphere and vice versa, creating an environment of immense chemical and thermal richness. Most crucially for our mystery, Juno's Waves instrument, which listens directly to the plasma and radio waves, has pinpointed the sources of the radio emissions with unprecedented accuracy. It confirmed that the decametric radio bursts are indeed tied to the magnetic flux tubes connecting to the moons, especially Io. However, it also found that these emissions are far more structured and localized than expected. The sources are not broad, diffuse regions, but incredibly concentrated, almost like pinpoint hotspots of intense radio generation within the larger auroral ovals. Even more intriguingly, Juno has detected ultra-relativistic electrons being accelerated in these regions to energies that push the limits of our understanding. These aren't just particles sliding down a magnetic field line. They're being catapulted to nearly the speed of light by a process that remains poorly understood. Some scientists have proposed that a kind of natural, planetary-scale particle accelerator is at work, but the mechanisms are still debated. From our speculative lens, such a powerful and focused acceleration process could also be interpreted as a signature of technology, a side effect of immense energy transfer or propulsion systems operating on a scale we can barely comprehend. The precise, structured nature of these radio hotspots, embedded within the broader chaos, continues to be one of the most tantalizing puzzles in the Juno dataset, a puzzle that refuses to be fully solved by conventional physics alone. This brings us to one of the most profound and unsettling possibilities of all, a concept that forces us to confront our own place in the cosmic pecking order. It's called the Zoo hypothesis, and it offers a chillingly elegant solution to the famous Fermi paradox, the bewildering question of why. If the universe is so vast and old, we see no clear signs of other civilizations. The hypothesis suggests that advanced galactic societies are indeed out there, and they are fully aware of our existence, but they have made a conscious, collective decision to avoid open contact, effectively placing our world in a kind of cosmic wildlife preserve or a designated anthropological study zone. They observe us from a distance, allowing our civilization to develop naturally without interference, perhaps until we reach a certain level of maturity or technological sophistication. Now, let's take this deeply humbling idea and apply it directly to the swirling giant in our own backyard. What if the hypothetical Jovians aren't just unaware of us or incapable of communicating? What if they are ignoring us on purpose? Consider the vast technological gulf this scenario implies. Our own civilization's electromagnetic signature is a mere century old, a fleeting blink in cosmic time. Our radio and television broadcasts, our early satellite transmissions, form a faint, expanding bubble of noise that has so far traveled a little over 100 light-years into the galaxy. To a civilization that has potentially existed for millions of years within the energetic furnace of Jupiter, a society that might communicate through modulated storms and think in currents of plasma, our primitive signals could be utterly beneath notice. Imagine an advanced research team studying an anthill in a vast forest. They are aware of the ants, they may even find their social structures mildly interesting, but they do not attempt to communicate with them using pheromones or by tapping on the ground. The ants' world is simply too different, their level of complexity too far removed to warrant a direct dialogue. In this analogy, we are the ants, and our frantic radio chatter is the equivalent of pheromone trails, a form of communication so rudimentary that it doesn't even register as intelligent discourse to a truly advanced entity. The Jovians, from their vantage point of immense power and antiquity, might view our planet as a quaint, pre-technological curiosity, a preserve of biological life that has yet to graduate to the larger cosmic community. This perspective also recontextualizes the very signals we've been examining. The powerful, structured radio bursts from Jupiter, which we speculate could be their technological leakage, might be something they either cannot or do not care to conceal. For a civilization so deeply integrated with its planet's fundamental forces, turning off this electromagnetic hum would be as impractical and unnatural as humanity deciding to halt all volcanic activity on Earth. Their technology and their very existence might be one and the same, generating a constant planet-wide radio signature as an inevitable byproduct. They wouldn't bother to hide it because, from their point of view, there's no one to hide it from, or at least no one who matters. The faint, unorganized whispers from the third rock from the sun would be dismissed as natural stellar static or the faint background crackle of a still-developing world. Their own broadcasts, in contrast, are the roaring conversation of a mature, fully actualized society going about its daily business, a conversation they have no reason to filter just because a lesser civilization has recently learned to eavesdrop. This leads to a fascinating inversion of our traditional search for intelligence. We have always assumed that a technologically superior culture would be meticulously efficient, perhaps even cloaking its energy signature to remain hidden. But what if the ultimate mark of a supremely advanced civilization is not stealth, but a kind of sublime indifference? They wouldn't need to hide because they would have nothing to fear. Their technology, their society, and their very form of existence would be so far beyond our comprehension that our attempts to contact them or interpret their signals would be as meaningful as a bacterium trying to get the attention of a human being by arranging itself into a pattern. The zoo hypothesis, when applied to Jupiter, suggests that the greatest barrier to contact may not be distance or technology, but a simple, profound lack of interest. We are not being greeted because we have not yet passed the entrance exam for the Galactic Club, and the members already inside are too preoccupied with their own vast affairs to notice us tapping on the glass. But if we are truly contemplating a civilization advanced enough to shape its entire world, then we must also consider the technology that would require and the kind of artifacts it might leave behind. We are familiar with the concept of a Dyson sphere, a hypothetical megastructure built around a star to capture its total energy output. Now, let's transpose that audacious idea from a star to a planet. What would a Jovian Dyson sphere look like? It wouldn't be a rigid, solid shell encasing the world. That's an impossibility in the churning, fluid environment of a gas giant. Instead, imagine a dynamic, living network, a planet-girdling web of energy collectors and processors designed not to capture sunlight, but to tap into the two most prodigious power sources Jupiter has to offer: its ferocious internal heat and its staggering rotational energy. Jupiter is a cosmic powerhouse in its own right, radiating more than twice the heat it receives from the Sun. This immense internal warmth, a relic from its violent formation and sustained by the slow gravitational compression of its atmosphere, drives the planet's titanic storms and complex weather. A truly advanced civilization would not let this energy go to waste. Their equivalent of a power grid could be a vast, floating archipelago of collector stations, suspended at different levels in the atmosphere. These wouldn't be metal boxes as we know them. They might be genetically engineered biological constructs or self-assembling plasma formations that thrive in the extreme conditions, acting like thermoelectric generators on a continental scale, drawing power directly from the thermal gradient between the deep, hot layers and the frigid upper cloud decks. The waste heat from these operations, dumped back into the atmosphere, could even explain some of the persistent, localized thermal anomalies we've observed, hotspots that seem to generate more energy than conventional models can account for. Yet, the internal heat is only half the story. Jupiter's rapid rotation is a reservoir of kinetic energy of almost unimaginable scale. The planet's 10-hour day means its equator is spinning at about 28,000 miles per hour. A civilization that learned to tap this spin could harness a fundamental force of the planet itself. Their megastructure might include a global system of electromagnetic tethers, immense, superconducting loops that interact with Jupiter's own magnetic field. As these loops cut through the planetary magnetic field, they would generate colossal electrical currents, effectively turning the entire planet into a gigantically powerful unipolar generator. The operation of such a system would be anything but quiet. The switching of these immense currents, the stabilization of the tethers against atmospheric shear, and the constant feedback with the magnetosphere would produce a torrent of electromagnetic interference. The powerful, structured radio bursts we detect could be the direct exhaust from this planet-wide power plant, the predictable and unavoidable static from a global civilization running its engines at full throttle. This concept reframes the Jovian radio signals from a potential language into a technological signature, a byproduct of industry on a scale we can barely fathom. The specific frequencies and modulations could correspond to different aspects of this vast network. The low-frequency, booming kilometric radiation might be the bass note hum of the main power distribution grid, the steady background output of the entire system. The more complex, pulsing decametric bursts could be the sharper crackle of individual switching stations coming online or offline, or the sound of massive energy transfers between different layers of the atmosphere. The quasi-periodic patterns that intrigue scientists might not be a message, but a diagnostic readout, the rhythmic pulse of a pump, the cycling of a cooling system, or the harmonic resonance of the entire network operating at peak efficiency. We wouldn't be listening to their conversations, we'd be hearing the industrial heartbeat of their world. This vision of a Jovian energy harvesting network also provides a potential answer to a lingering question. Why would a civilization broadcast so loudly and indiscriminately? The answer is simple: they might not have a choice. The energy scales involved in managing a planet's internal and rotational forces are so astronomical that containing the electromagnetic byproduct could be physically impractical or energetically prohibitive. For us, containing radio leakage from a cell tower is trivial. For them, containing the radio roar from a system that moves oceans of energy might be like trying to silence a hurricane. Their technological foundation is built upon harnessing forces that inherently generate a deafening electromagnetic scream, a scream that their own senses might even be tuned to ignore, just as we learn to tune out the constant hum of a city. So, while we on Earth search the silent stars for a deliberate whisper, the most obvious sign of an advanced intelligence in our solar system may have been shouting its presence all along, not in a language of words, but in the magnificent, thunderous roar of its impossible machines. For centuries, the Great Red Spot has been an icon of our solar system, a swirling crimson eye staring out from Jupiter's dynamic face. We've long accepted it as the pinnacle of natural weather, a hurricane larger than our entire planet that has raged for at least 400 years. But when you truly begin to scrutinize this storm, its characteristics start to look less like a simple act of nature and more like something engineered. The first and most glaring anomaly is its sheer longevity. On Earth, even the most powerful hurricanes are fleeting phenomena, dissipating after a few weeks once they lose access to the warm ocean waters that fuel them. Jupiter's atmosphere has no such obvious, concentrated energy source. The Great Red Spot is a vortex, a high-pressure anticyclone, and while models can create long-lived vortices in simulations, maintaining one with such ferocious stability for centuries against the chaotic backdrop of Jupiter's jet streams is a monumental puzzle. It's as if a single, perfect whirlpool persisted in the middle of the ocean, not for days but for hundreds of years, resisting all the forces that should have torn it apart. This isn't just a storm, it's a persistent, self-sustaining system of incredible resilience, and that kind of persistence naturally invites a more speculative question: could it be maintained on purpose? Consider its structure and behavior. Data from spacecraft like Juno has revealed that the Great Red Spot is not a shallow weather feature. Its roots plunge deep into the atmosphere, perhaps 200 miles or more, tapping into the planet's internal heat flows. This profound depth gives it a stability that a surface-level storm could never achieve, but it also makes its stark boundaries and organized internal structure even more remarkable. The outer winds whip around its perimeter at speeds exceeding 250 miles per hour, creating a terrifyingly sharp wall of clouds that separates the storm's interior from the surrounding atmosphere. Inside, however, the environment is strangely different. The core is calmer, warmer, and exhibits a complex, layered structure. From our speculative viewpoint, this arrangement, a hyper-energetic protective barrier surrounding a more stable, structured interior, doesn't just resemble a storm, it mirrors the design of a facility. Think of a secured industrial plant or a city on Earth, often surrounded by perimeter defenses, with the controlled, organized activity happening safely inside. What if the Great Red Spot functions in a similar way? Its furious outer wall could be a purposeful structure, a way to contain and protect whatever processes are occurring within its vast, red-hued interior. So, what could those processes be? If we entertain the idea of a Jovian civilization, the possibilities are as staggering as the storm itself. One compelling notion is that the Great Red Spot is a colossal atmospheric processing facility. Jupiter's atmosphere is a rich soup of chemicals: water, ammonia, methane, and complex organic compounds, all churned together by powerful winds. A society living in that environment would need a reliable way to harvest and refine these resources. The storm's immense rotational energy and deep roots could be acting as a natural centrifuge, a planet-scale machine that separates and concentrates specific molecules from the chaotic atmospheric soup. The different colored bands within the spot, the variations in temperature and composition, might not be random weather patterns, but the visible signature of different refinement stages, with valuable resources being siphoned off for use by the civilization that built or maintains this incredible structure. The characteristic red color itself, often attributed to complex chemicals like sulfur or phosphorus brought up from deeper layers, could be the industrial smog, the unintended byproduct of this immense chemical engineering. Another, even more profound possibility is that the Great Red Spot isn't a factory at all, but a metropolis. For beings that live suspended in the Jovian sky, a stable, long-lived atmospheric structure would be the most valuable real estate imaginable. The storm's energetic boundaries would provide a natural defense against the turbulent weather outside, creating a protected habitat. The calmer, warmer interior could be their living space, a vast, three-dimensional city where floaters or sinkers congregate. Their buildings might not be structures of steel and glass, but persistent, organized cloud formations, complex vortices within the larger vortex that serve as homes, communal spaces, or energy collectors. The strange internal circulations and heat signatures detected by Juno could be the metabolic output of a teeming alien population, their collective activity subtly shaping the dynamics of their city storm. In this scenario, we are not looking at a random act of weather, but at the engineered home of a civilization, a permanent settlement that has endured for centuries, its crimson glow the collective light of countless lives. This perspective also offers a potential explanation for the spot's recent, well-documented changes. Astronomers have noted that the storm is shrinking and becoming more circular. While a natural explanation points to interactions with smaller storms and jet streams, the civilization hypothesis provides an alternative narrative. Perhaps what we are witnessing is not a slow death, but a period of urban renewal or a controlled downsizing. An advanced society would constantly maintain and optimize its infrastructure. The changing shape and size could reflect a deliberate re-engineering project, an adaptation to new energy needs or population dynamics. Or it could be a response to the larger shifts in Jupiter's climate over its 12-year orbital cycle, a seasonal adjustment made by a culture utterly in tune with its planet's rhythms. The fact that the storm remains coherent and powerful even as it changes form is in some ways more suggestive of intelligent management than of a natural phenomenon in decline. A purely natural vortex would be expected to eventually fragment and dissipate. An intelligently managed one would evolve. The Great Red Spot, therefore, stands as the ultimate test of our imagination. It challenges us to decide if we are looking at the solar system's most magnificent storm, or if we are gazing, unknowingly, upon the sky-born capital of a world we are only just beginning to hear. But our investigation cannot stop with radio waves alone, for Jupiter's secrets are written across the entire electromagnetic spectrum. To truly see the giant, we must also observe its heat, its thermal portrait painted in the invisible light of infrared. When we point our most sensitive infrared telescopes toward Jupiter, we see a world glowing with the energy of its own creation, a colossal engine radiating more heat than it receives from the distant sun. This internal furnace drives the planet's ferocious weather, but when astronomers map this thermal output in fine detail, they find puzzling inconsistencies. Scattered across the cloud tops are unexplained hotspots and thermal anomalies, localized regions that burn significantly brighter or dimmer than the surrounding atmosphere, and they don't always align with the visible cloud patterns or the models predicting Jupiter's weather. These are not the broad, predictable warmth of equatorial bands or the chill of polar regions. They are sharp, specific, and sometimes transient signatures of excess energy with no immediately obvious source, like finding a series of unexplained bonfires blazing across a vast, dark landscape. Consider the nature of this waste heat. On Earth, if you were to fly over a major city at night, you would see it glowing brightly in the infrared, a clear thermal signature of human activity. The collective energy from our homes, vehicles, and industries escapes as waste heat, creating an unmistakable thermal footprint that sets our urban centers apart from the natural countryside. Now scale that concept up to a Jupiter-sized civilization. If a technologically advanced society operates on a planetary scale, whether they are floating biological entities or sentient plasma, their activities would inevitably generate immense amounts of waste heat. Their power generation, their manufacturing, their computation, their very metabolism, all of it would ultimately dissipate as thermal energy. These enigmatic hotspots we detect could be the Jovian equivalent of those glowing cities, the thermal exhaust from vast, concentrated technological hubs operating deep within the atmosphere. The reason they don't correlate perfectly with visible weather patterns is simple. They are not weather. They are the byproduct of industry, the thermodynamic price paid for a civilization's existence, and they shine forth in the infrared as beacons of something more than mere natural processes. Yet, technology is not the only possible source for this anomalous heat. We must also confront an even more biologically thrilling possibility, that we are detecting the metabolic warmth of life itself, but on a scale so vast it defies all terrestrial comparison. Imagine the hypothetical floaters, those colossal, buoyant beings drifting in the Jovian skies. If such creatures exist, their sheer size would be difficult to comprehend, potentially spanning dozens of miles across. A biological entity of that magnitude would have a significant metabolism, a process of converting chemical energy from the atmosphere into the energy of life. This internal biochemical engine would generate heat, and for a creature of that scale, that heat signature could be detectable against the cold background of the upper cloud decks. A school of such creatures, or a massive migration of them, could easily manifest as one of these transient, unexplained thermal anomalies, a warm patch that appears, moves in a way that defies simple wind patterns, and then dissipates as the beings move on or dive into deeper, warmer layers of the atmosphere. To grasp this fully, picture a blue whale in our own oceans. Its large body maintains a core temperature warmer than the surrounding water, a thermal signature that could, in theory, be detected by a sensitive enough scanner. Now magnify that whale to the size of a mountain and place it in an atmosphere where the background temperature is a consistently frigid -140 degrees Celsius. The contrast would be stark. The body heat of a single, immense floater could create a localized thermal bloom, a spot of warmth that stands out clearly on an infrared map. If these beings are social, gathering in vast herds or congregations for breeding or feeding, their collective metabolic output could create a massive, complex thermal signature that pulses and shifts over time, appearing to our instruments as a mysterious, evolving hotspot of unexplained origin. This line of thinking forces us to re-evaluate the very data we have collected for decades. Missions like the Juno spacecraft carry instruments that measure Jupiter's thermal radiation with incredible precision, and they have indeed mapped regions of surprising and complex heat distribution. Some of the most persistent anomalies are found near the poles, associated with the chaotic clusters of cyclones, but others appear at lower latitudes, disconnected from any major atmospheric features we can identify. Could one of these be the thermal plume from a submerged metropolis, where waste heat from countless living spaces and technological processes percolates upward to warm the cloud tops above? Or might another be the grazing ground for a population of sinkers, whose deep dives into the warm interior and subsequent returns to the cooler upper layers create a fluctuating thermal signal as they move. The infrared sky of Jupiter, it turns out, may not be a passive canvas of weather, but a dynamic and living display, its unexplained hotspots serving as potential markers for the presence, the industry, and the very life of a civilization we are only just learning how to see. So far, we've kept our gaze fixed on Jupiter itself, imagining civilizations floating in its clouds or thinking within its magnetic storms. But to truly grasp the scale of what might be happening in that corner of our solar system, we need to widen our view to include Jupiter's stunning family of moons. This isn't just a collection of barren rocks, it's a miniature solar system in its own right, dominated by 4 colossal worlds: Io, Europa, Ganymede, and Callisto. And for 3 of these, the story isn't written on their surfaces, but hidden deep beneath them, in global, liquid water oceans that could hold more water than all of Earth's oceans combined. If a native Jovian intelligence exists, why would it limit itself to the atmospheric realm? A truly advanced civilization, one capable of harnessing the energy of a gas giant, would almost certainly view these watery moons not as distant, icy outposts, but as the next logical frontier for expansion, resource harvesting, and perhaps even colonization. Let's start with Europa, a world that has captivated scientists and storytellers alike. Its surface is a cracked, frozen tapestry of brownish lines crisscrossing a pristine shell of water ice. But beneath that icy crust, perhaps only 10 or 20 miles down, lies a global saltwater ocean, kept liquid by the relentless gravitational kneading from Jupiter. This subsurface sea is one of the most promising places in our entire solar system to look for life. But for our hypothetical Jovians, Europa would represent something else entirely, a vital reservoir. Water is the solvent of life as we know it, but it's also a fundamental resource for industry. It can be split into hydrogen and oxygen for rocket fuel, used for cooling, or serve as a medium for chemical processes. A civilization that evolved in Jupiter's hydrogen-helium atmosphere might view liquid water with the same strategic importance that an industrial society views oil or rare earth minerals. Establishing a base on or within Europa's ice shell would grant them direct access to this incredibly valuable commodity. They wouldn't need to drill. Their technology might allow them to melt their way down, creating hidden docking ports at the boundary between the ice and the ocean, or even constructing entire submerged facilities in the dark, pressurized waters below. Then there is Ganymede, the largest moon in the entire solar system, even bigger than the planet Mercury. Ganymede is a world of profound complexity, with a unique, intrinsic magnetic field and a subsurface ocean likely sandwiched between layers of ice. Its surface is a chaotic mix of dark, ancient terrain and lighter, grooved areas, suggesting a long and dynamic geological history. For a spacefaring civilization, Ganymede's size and complexity would make it a prime candidate for a major hub. Its magnetic field could be harnessed for energy, much like Jupiter's own, and its varied geology would offer a wealth of mineral resources not available in the gas giant's homogeneous atmosphere. One can imagine a Ganymede outpost not as a simple research station, but as a sprawling industrial center, a shipyard for constructing vessels designed to travel the Jovian system. The operations required to mine the moon's crust, process its materials, and launch spacecraft from its surface would be anything but quiet. The electromagnetic noise from such an industrial base, from powerful ground-penetrating radar mapping subsurface deposits to the intense comms traffic coordinating logistics, would be immense, and it would all be happening deep within Jupiter's magnetosphere. This localized, moon-based radio chatter would then be picked up, amplified, and projected outward by Jupiter's own magnetic transmitter, blending seamlessly with the planet's natural radio roar and adding another layer of intricate complexity to the signals we receive. This vision of an interconnected Jovian empire also solves a key problem of living in a gas giant, the lack of solid ground. While a civilization of floaters or plasma beings might be perfectly content in the atmosphere, the development of advanced technology often requires stable foundations, extreme temperatures, and access to a diverse portfolio of elements. The intense pressure, corrosive chemistry, and violent storms of Jupiter would make building delicate, complex machinery extraordinarily difficult. The moons, with their solid, stable surfaces and rich deposits of silicates and metals, provide the perfect industrial parks. Callisto, the most heavily cratered and geologically quiet of the large moons, could serve as a secure, long-term archive or a remote monitoring station, its ancient surface a silent witness to eons of activity. The transportation network between these moons and Jupiter would be the lifeblood of this empire. We might not be looking for sleek, silver starships, but for something far more integrated with the environment. Transportation could involve riding the very magnetic flux tubes that connect the moons to the planet, using them as guided pathways for energy-based travel. Or it could involve vast biological vessels, living ships grown for the purpose of carrying resources and beings through the void, their propulsion systems creating unique, pulsed electromagnetic signatures as they maneuver. This grand, system-wide perspective reframes the entire mystery of the radio signals. The complex modulations and quasi-periodic patterns we detect may not be a single, monolithic broadcast from Jupiter, but a tangled symphony of countless sources. It could be the combined output of planetary weather, atmospheric industry, moon-based operations, and the comms traffic between them all. The signal becomes a conversation not just between individuals on Jupiter, but between outposts across millions of miles of space. A pulse we detect might be a navigation beacon from a transport vessel approaching Europa, followed by a data burst from a mining operation on Ganymede acknowledging its arrival, all superimposed over the steady, booming hum of Jupiter's own power grid. The reason the signal is so powerful and so complex is that we are not listening to one civilization. We are listening to the electromagnetic heartbeat of an entire, integrated empire, a network of activity spanning multiple worlds, all broadcasting their existence simply by going about their daily business. The silence we perceive from the other gas giants might then be explained not by their lack of natural activity, but by their lack of such a diverse, resource-rich lunar system to support and amplify the growth of a civilization to an interstellar scale. For decades, the haunting question posed by physicist Enrico Fermi has echoed through the halls of science. If the universe is so vast and ancient, teeming with billions of stars and planets, then where is everybody? This is the Fermi paradox, the bewildering silence that greets our search for other intelligent life. We have scanned the heavens for a deliberate hello, a structured signal from the stars, and found only a profound and lonely quiet. But what if the entire premise of our search has been backwards? What if the solution to the great silence is not out there in the deep black, but right here, hidden in plain sight? The Jovian civilization hypothesis presents a stunningly direct answer. They are not missing. They are here. We have simply been listening for the wrong kind of signal in the wrong kind of place, our gaze fixed so firmly on the stars that we failed to recognize the civilization thrumming with life in our own cosmic backyard. Our traditional approach to the search for extraterrestrial intelligence has been fundamentally shaped by a single, powerful assumption that an advanced civilization would want to talk to us. This led to the pursuit of a deliberate beacon, a tidy, narrow-band signal purposefully beamed across the light years. We searched for a cosmic handshake, an intentional message. But this assumes that other intelligences share our communicative instincts and our technological methods. It's a profoundly human-centric viewpoint. The roaring, complex radio bursts from Jupiter offer a radically different paradigm. This is not a beacon. It is not a message meant for anyone's ears. It is the unavoidable, spectacular leakage from a society so advanced that its daily operations are indistinguishable from the natural fury of its planet. We weren't looking for this because we didn't know what to look for. We were searching for a carefully composed letter in the interstellar mail, while ignoring the fact that our neighbor's entire city was screaming its existence through a megaphone made of storms. The Fermi paradox isn't a statement about the absence of life. It's a testament to the limitations of our imagination. Consider the sheer cosmic irony of our position. For over half a century, giant radio dishes like the Allen Telescope Array have been painstakingly pointed toward distant, sun-like stars, sifting through the static for a whisper of intelligence. All the while, the single most powerful and complex source of radio emissions in our entire sky, aside from the sun, has been Jupiter. We have catalogued its signals, explained many of them through elegant plasma physics, and then systematically filed them away as solved. We dismissed the most obvious candidate for a non-human technosignature because it didn't fit our preconceived storybook notion of what an alien signal should be. It was too loud, too messy, too integrated with a natural process. In doing so, we may have committed the greatest error in the history of our search for company. We tuned out the one frequency that was actually broadcasting a civilization, simply because it sounded too much like the weather. This reframing elegantly resolves the tension at the heart of the Fermi paradox. The question, "Where is everybody?" is immediately answered with "They are at Jupiter." The great silence is broken not by a signal from 1,000 light-years away, but by a roar from just over 500 million miles distant. The reason we haven't made contact is not because they are not there, but because their very existence is so alien that we lack the conceptual framework to recognize it. A civilization living within the fluid dynamics and magnetic storms of a gas giant is not building radio telescopes to point at Earth. Its concerns, its technology, and its perception of reality are built on a foundation we are only beginning to comprehend. They are not hiding, they are being themselves, and their natural state of being generates an electromagnetic signature so powerful that it washes over us regularly, a constant, booming reminder that we are not alone, if only we would broaden our definition of what life and intelligence can be. This also addresses the deeply troubling Great Filter hypothesis, which suggests that some insurmountable obstacle prevents life from progressing to an interstellar stage. Perhaps the filter is not ahead of us but behind us. Maybe the challenge is not surviving our own technology or overcoming some galactic barrier, but something far more fundamental: the ability to recognize other forms of intelligence that do not conform to our own biological and technological template. The filter might be perceptual. If a civilization as vast and powerful as a potential Jovian society can exist right next to us and remain effectively invisible to our standard search methods, then the galaxy could be teeming with life, all similarly camouflaged within what we arrogantly dismiss as natural phenomena. The silence of the stars is not empty. It is likely filled with the complex, disguised hum of countless worlds, each speaking in a unique language we have not yet learned to hear. By solving the puzzle of Jupiter, we wouldn't just be finding one alien civilization. We would be cracking the code to a universe that has been talking to us all along. Now, it is absolutely essential that we pause here and directly confront the single most powerful objection to this entire extraordinary idea. For every breathtaking leap of imagination, there stands a bedrock principle of science urging caution. And we would be doing this mystery a profound disservice if we did not give the skeptical viewpoint its full and fair voice. The most formidable tool in the skeptic's arsenal is a 700-year-old philosophical principle known as Occam's razor. In its simplest form, it advises that when you are presented with competing explanations for a phenomenon, you should generally lean toward the one that makes the fewest new assumptions. You favor the simpler, more straightforward answer, and when we apply this razor-sharp logic to the Jovian radio bursts, the conclusion seems overwhelmingly clear. We have a perfectly functional, well-tested, and scientifically elegant explanation that requires no new physics and no grand assumptions about alien life. We have the violent, beautiful, and entirely natural dance of charged particles in a magnetic field. Let's be unequivocally clear about what that natural explanation entails. The universe of plasma physics is not a simple one. We are not talking about billiard balls clicking together in a predictable way. Plasma, often called the fourth state of matter, is a seething, chaotic soup of ions and electrons, and when you immerse it in a magnetic field as monstrous as Jupiter's, you create a system of almost limitless complexity. The motions and interactions within this plasma are governed by the laws of electromagnetism, and these laws can give rise to an astonishing variety of behaviors that can, to our pattern-seeking brains, look incredibly organized. Think of a fast-flowing river. As the water rushes over and around rocks, it creates stable, swirling vortices that can persist for minutes or even hours. These whirlpools are structured, they are persistent, but they are utterly mindless. They are an emergent property of the fluid dynamics. In the same way, the intricate patterns of clicks and pulses we hear in Jupiter's radio emissions could be the electromagnetic equivalent of these fluid whirlpools. They are stable structures that naturally emerge from the chaotic flow of energy, not because they are engineered, but because the physics of the system allows for, and even encourages, such formations to exist. Scientists can actually recreate versions of this complexity in laboratories and in sophisticated computer simulations. When they model the conditions within Jupiter's magnetosphere, with its immense electrical currents and swirling plasma, the simulations spontaneously generate a zoo of radio phenomena. They produce bursts, hops, and sudden dropouts in signal strength. They create emissions that drift in frequency and exhibit harmonic relationships. All of this emerges from the fundamental mathematics of moving charges and shifting magnetic fields. There is no secret code being written. It is the inherent, noisy music of a natural cosmic engine. To insist that these patterns must be artificial is, from this perspective, a classic example of anthropomorphism, the human tendency to impose our own experience of design and intention onto processes that are, in reality, completely impersonal. We hear a series of clicks that sounds like Morse code because our brains are hardwired to find signals in noise, a trait that once helped our ancestors detect predators in the rustling grass, but which can now lead us to see faces in the clouds and cities in the storms of Jupiter. Furthermore, the skeptics would rightly point out a critical flaw in leaping to the civilization hypothesis, the problem of energy efficiency. If you were an advanced society trying to communicate or even just power your world, you would likely strive for efficiency. You would focus your energy into tight, coherent beams and use sophisticated modulation to pack as much information into as little bandwidth as possible, minimizing waste. But the Jovian radio bursts are the polar opposite of efficient. They are spectacularly wasteful. They are broadband, blasting across a huge swath of the radio spectrum all at once, like trying to have a private conversation by screaming at the top of your lungs in the middle of a hurricane. This is exactly what you would expect from a natural, turbulent process where energy is being dissipated chaotically. It is not the signature of a technology. It is the signature of raw, untamed power running amok. The fact that these signals are so loud and so messy is, for many scientists, the most compelling evidence that we are listening to nature in its most unbridled form, not to the calibrated output of a conscious mind. Perhaps the most decisive argument against the need for an intelligent designer is the stunning success of the natural models in predicting these signals. The connection between Eo's orbital position and the timing of the strongest decametric bursts is not a loose correlation. It is a precise, predictable relationship. Scientists can calculate when Eo will be in the right position to trigger a radio outburst, and their predictions are consistently borne out by observation. This is the gold standard of science. When a model allows you to successfully forecast an event, it demonstrates a deep understanding of the underlying mechanics. The fact that the plasma physics model achieves this with such high reliability is a massive point in its favor. It means the core engine of the phenomenon is not only understood but is practically demonstrable. The occasional anomalies and complex patterns that don't perfectly fit the model are not seen as evidence of something else, but rather as puzzles within the existing framework, details that demand a more refined understanding of the plasma turbulence, not an entirely new paradigm involving sentient beings. So, where does this leave our grand speculation? In the cold, hard light of scientific rigor, the civilization hypothesis appears as a beautiful, fascinating, but ultimately unnecessary complication. It is a narrative we are drawn to because it speaks to our deepest hopes and our innate curiosity. But the universe, as we have repeatedly learned, has no obligation to conform to our desires for companionship. The natural explanations are powerful, predictive, and elegantly rooted in known physics. They paint a picture of a cosmos that is capable of generating awe-inspiring complexity and false signatures of order all on its own. A universe where the simple, mindless interaction of force and matter can create illusions so compelling that they can captivate us for generations. This is not a dismissal of wonder, but a redirection of it. The true marvel may not be that Jupiter harbors a hidden civilization, but that the laws of physics themselves are rich and creative enough to produce a phenomenon that so perfectly teases the boundaries of our imagination, challenging us to tell the difference between a cosmic accident and a hello that was never there. Given the sheer number of worlds just like Jupiter that we now know are out there, we have to completely reconsider one of the most famous equations in the search for alien life, the Drake equation. Conceived by astronomer Frank Drake in the early 1960s, this formula was designed to provide a structured way to estimate the number of civilizations in our Milky Way galaxy that we might be able to communicate with. It multiplies a series of factors, starting with the rate of star formation and moving through the fraction of stars with planets, the number of planets that could support life, the fraction where life actually emerges, the fraction where that life becomes intelligent, the fraction that develops detectable technology, and finally, the length of time such a civilization releases those signals into space. The result of this long chain of variables is n, the number of communicative civilizations in our galaxy. Traditionally, when scientists plug in what they consider to be reasonable numbers for these factors, the results can be disheartening, suggesting that n might be very small, leaving us profoundly alone in a galaxy of hundreds of billions of stars. But this entire framework is built on a single, unshakable assumption: that life, and especially intelligent life, requires a planet like Earth. It assumes a rocky world orbiting within a star's habitable zone with a solid surface and liquid water. This habitable zone concept is our gold standard, a narrow orbital band where temperatures are just right for water to remain liquid. It's a comfortable, familiar idea, but what if it's also a deeply limiting one? The moment we allow for the possibility of life within gas giants, the Drake equation transforms. The variable for the number of planets that could support life, often denoted as n sub e, explodes in value. Think about our own solar system. We have one Earth, a single rocky world in the Sun's habitable zone, but we also have four gas giants: Jupiter, Saturn, Uranus, and Neptune. And while Saturn, Uranus, and Neptune may be quieter, they are still massive, complex worlds with deep atmospheres and internal energy sources. If even a fraction of them could harbor life, the number of potentially habitable worlds in our own backyard immediately multiplies. Now extend that logic across the galaxy. The Kepler Space Telescope and other observatories have taught us that gas giant planets are not cosmic rarities, they are commonplace. Many star systems have multiple gas giants. More importantly, these planets do not need to orbit within the narrow, sun-drenched habitable zone to be warm. A gas giant like Jupiter produces its own immense internal heat. left over from its formation and sustained by the slow gravitational compression of its atmosphere. This means a gas giant can be habitable all on its own, completely independent of its distance from its parent star. It could be drifting alone in the dark between stars as a rogue planet, and its deep, warm atmospheric layers could still provide a stable, energy-rich environment for life. Suddenly, the galaxy is not dotted with a few rare, Earth-like oases, but is absolutely teeming with potential habitats, billions upon billions of swirling gas giants, each one a world of possibilities. This recalculation fundamentally changes our estimate of n, the number of civilizations. The traditional approach makes several of the factors in the Drake equation seem incredibly small. The fraction of planets where life actually appears, the fraction where life becomes intelligent. These are often seen as the great filters, the tiny, improbable bottlenecks that prevent the galaxy from being crowded with intelligence. But if life can emerge in the atmospheres of gas giants, these probabilities might not be so slim. Life on Earth began in our oceans, a fluid medium rich with chemistry. The upper cloud decks of a gas giant are not so different. They are a vast global ocean of gas stirred by winds and energized by internal heat and lightning, filled with water, ammonia, methane, and complex organic molecules. The building blocks of life are there, and the immense scale and stability of these environments could actually make the emergence of life more likely, not less. A gas giant's habitable zone isn't a thin skin on the surface. It's a deep, three-dimensional volume thousands of miles thick, offering countless niches and a stability that can persist for billions of years. The path to intelligence might also be more direct. On Earth, intelligence emerged in a species that had to navigate a complex, three-dimensional social and physical world in the trees and on the savanna. In the endless, three-dimensional skies of a gas giant, the evolutionary pressure to develop sophisticated sensory processing, navigation, and communication would be intense and constant. Intelligence might not be a rare fluke, but a common evolutionary outcome in such a demanding environment. So, let's animate this new galactic vision in our minds. Instead of picturing a star chart with a few lonely, Earth-like planets highlighted in green, imagine a galaxy awash with light. Every single star system, and even the dark spaces between them, glows with the potential for life. Countless gas giants, each one a swirling marble of clouds and storms, become the primary abodes for intelligence. Their civilizations would be as varied as the planets themselves. Some around younger, hotter stars might be vast societies of floaters basking in the energetic upper atmospheres. Others, around dim red dwarfs or floating freely in deep space, might harbor civilizations of sinkers who have mastered the deep, warm, high-pressure layers, their technologies based on the strange physics of liquid metallic hydrogen. Their detectable signatures would not be the faint, deliberate beacons we once looked for. The galaxy would be filled with a cosmic static, a low roar of electromagnetic noise that we have always mistaken for natural background radiation. It would be the combined, unintentional technosignature of billions of advanced societies, each one so integrated with its world that its daily operations are indistinguishable from the weather. The great silence described by the Fermi paradox would vanish, not because we finally received a message, but because we finally understood that the silence was an illusion. We had been listening for a whisper in a crowded, roaring stadium and thought the room was empty. The universe isn't lonely, it's bustling with a form of life so grand and so alien that we are only just beginning to learn how to see it. Moving from the profound speculation of what might be to the concrete question of how we could know brings us to the most exciting frontier of all, the future missions and experiments that could finally test this extraordinary hypothesis. This isn't about idle wonder anymore, it's about building the tools and designing the strategies that could turn a captivating what if into a definitive we found something. The path forward requires a multi-pronged assault, combining sophisticated new spacecraft, revolutionary data analysis, and a fundamental shift in what we instruct our machines to look for. First and most critically, we must go deeper into the atmosphere itself. While orbiters like Juno have given us an unparalleled view from above, the true secrets are locked within the churning cloud decks. To find them, we need to send down not just a single probe, as the Galileo mission did in 1995, but a veritable fleet of next-generation atmospheric explorers. Imagine launching a mission that deploys dozens of small, resilient probes, released at different latitudes and longitudes to create a global sensor network suspended in the Jovian sky. These wouldn't be one-off, short-lived devices. They would be designed for longevity, perhaps using the planet's own atmospheric dynamics to stay aloft for months or even years. Their instrument suite would be explicitly designed to hunt for the fingerprints of a complex system. Beyond simple temperature and pressure sensors, they would carry advanced chemical spectrometers capable of detecting anomalous ratios of complex organic molecules or industrial byproducts that shouldn't exist in a sterile environment. They would listen for low-frequency acoustic signatures, the equivalent of underwater sonar in this dense, gaseous ocean, searching for organized, repeating sound patterns that stand out from the random noise of wind and storm. A single probe finding a strange chemical signature could be a fluke, but a networked fleet all detecting the same anomalous, structured signal from different parts of the planet. That would be the kind of coordinated, global evidence that would force a complete scientific reevaluation. Simultaneously, our orbital presence needs a dramatic upgrade, specifically in how we listen. We require a dedicated radio observatory in orbit around Jupiter, a spacecraft whose sole purpose is to dissect the planet's electromagnetic roar with a sensitivity and resolution we can only dream of from Earth. Our current observations are like trying to analyze a symphony from outside the concert hall, hearing the blended roar of the entire orchestra. A dedicated orbiter, like a Jovian eavesdropper mission, would place its microphone right inside the concert hall. It could perform extremely long baseline interferometry, using multiple antennas to pinpoint the exact origin of every burst and chirp within the magnetosphere with surgical precision. Is that complex sequence of pulses coming from the chaotic polar region, or is it emanating from a surprisingly specific, stable point deep within the mid-latitudes? Does the structured signal change when Io is in a specific position, or does it operate on its own independent clock, suggesting a source unrelated to the Moon's influence? This orbiter would also be tuned to listen for signals we currently ignore. Our traditional SETI searches focus on narrow-band transmissions, but a Jovian technology might use spread spectrum techniques or complex, frequency hopping patterns that look like noise to our current algorithms. By mapping the entire radio spectrum around Jupiter in excruciating detail, we could build a three-dimensional dynamic map of its emissions, revealing structures and patterns that are completely invisible to us now. Back on Earth, we are sitting on a potential goldmine of untapped data. For over half a century, radio telescopes have been passively recording Jupiter's emissions, amassing petabytes of information that were analyzed with only the natural plasma physics model in mind. Buried within those decades of magnetic tape and digital files could be the very clues we're now looking for, missed simply because no one was searching for them. This is where the power of modern artificial intelligence becomes a game changer. We can now train sophisticated AI systems, particularly deep learning neural networks, to sift through this historical archive with a new set of eyes. Instead of teaching the AI to recognize only known natural patterns, we would train it to be an anomaly hunter. We would feed it simulated data of both natural plasma emissions and various types of potential artificial signals, leakage from power grids, structured communication protocols, even the kind of complex pulsed patterns a plasma-based intelligence might generate. The AI would learn the statistical texture of natural noise and then flag any signal in the historical data that deviates from that texture in a significant way. It could identify subtle, recurring patterns that are too complex for the human brain to detect over long timescales, perhaps finding that a specific, weird chirp occurs every 37 Jovian rotations, a periodicity with no known natural explanation. This approach turns our past efforts into a new experiment, leveraging our vast investment in astronomy to ask a question we weren't asking before. Ultimately, proving such a radical idea would demand a convergence of evidence from multiple, independent directions. It wouldn't be one single smoking gun, but a preponderance of clues that together become overwhelming. Imagine the scenario: the AI sifts through old data and flags a persistent, complex radio pattern originating from a specific region near the equator. The new Jovian eavesdropper orbiter confirms the source and finds it's modulated in a way that matches the efficiency of a compressed data stream. Meanwhile, the fleet of atmospheric probes drifting through that very same region detects simultaneous, coordinated spikes in certain complex hydrocarbons and an unusual thermal signature. No single piece of evidence proves the case on its own, but together they paint a picture that is impossible to explain through geology and atmospheric physics alone. This is the meticulous, patient work of true discovery. It requires us to be bold in our questions but rigorous in our methods, building a case piece by piece until the conclusion becomes inescapable. The search for a Jovian civilization is not a passive act of listening. It is an active technological safari into the most extreme environment in our solar system, a hunt for a form of intelligence that would redefine our place in the cosmos forever. And so we arrive at the ultimate question, the one that gives this entire investigation its breathtaking weight. What if it's true? What if the static finally resolves, the data converges, and we achieve a moment of absolute, universe-shattering certainty? We are not alone, and we never have been. The implications of such a discovery would ripple through every facet of human existence with a force greater than any event in our history, fundamentally reordering our understanding of our place in the cosmos in ways we can only begin to imagine. This wouldn't be a signal from 1,000 light years away, a distant abstraction that we could ponder safely from afar. This would be a civilization next door, a presence in our own celestial neighborhood, and the shock waves of that realization would be immediate and profound. First and most deeply, it would trigger nothing less than a philosophical and spiritual earthquake, shattering the anthropocentric worldview that has underpinned human culture for millennia. Since the dawn of consciousness, we have placed ourselves at the center of the narrative. Our religions, our myths, and even much of our early science positioned humanity as the special, chosen inhabitants of a universe created for us. The Copernican revolution began the process of dethroning us physically, showing us we were not the geographic center of the cosmos. Darwin's theory of evolution showed we were not a separate, divine creation, but part of the natural world's slow, meandering tapestry. The discovery of a Jovian civilization would be the final, decisive blow to this cosmic vanity. It would prove conclusively that we are not the universe's sole focus, its only thinkers, or its pinnacle achievement. We would be forced to confront the humbling reality that we are one form of intelligence among others, a single thread in a vast and likely much richer tapestry of conscious experience. The question, "Are we alone?" would be answered with a resounding no, and the new, terrifying, and exhilarating question would become, who else is out there, and what does our shared universe truly look like through their eyes? This shift would force a radical redefinition of life itself. Our entire biological sciences are built on a single data point, terrestrial life based on carbon, water, and DNA. We search for life on other worlds by looking for the specific chemical signatures we know. A Jovian intelligence, whether it is a biological floater or a sentient storm of plasma, would smash that limited framework to pieces. It would prove that the phenomenon of life is not a rare and fragile accident tied to a very specific set of planetary conditions, but a robust, creative, and universal force. Life, we would learn, can emerge in environments we once considered hellish, use solvents we consider toxic, and build its society on foundations of energy and information we are only beginning to comprehend. Textbooks of biology, chemistry, and even physics would need new chapters, whole new volumes, in fact dedicated to the principles of non-terrestrial life. The very definition of alive would expand to include possibilities we currently relegate to science fiction, forcing us to ask not just what is life, but what can life be. The scientific and technological windfall would be beyond calculation. Imagine having a tutor that is potentially millions of years more advanced than we are. We wouldn't need to decode a formal message or receive a set of blueprints. Simply by observing their existence, by studying the byproducts of their civilization, we would gain access to a graduate-level education in physics and engineering. Their ability to thrive within Jupiter's immense pressures, harness its titanic magnetic fields, and potentially structure its very weather patterns would imply a mastery of energy, materials science, and systems engineering that dwarfs our own. The structured radio pulses we detect might not be a language we can translate, but they could be a masterclass in information theory, showing us how to pack immense amounts of data into a noisy channel. The stable, geometric storm patterns at the poles could teach us new principles of fluid dynamics and self-organization. Their very longevity would offer a powerful lesson in sustainability. A civilization that has endured for eons within a closed system like a planet has necessarily solved problems of energy and resource management that we are still grappling with on our own world. They would be a living, breathing demonstration of technologies and sciences we haven't even dreamed of yet, offering us a shortcut across centuries of research and development. Culturally and socially, the impact would be as disruptive as it is unifying. The initial reaction would likely be a mixture of awe, fear, and global introspection. The familiar divisions that dominate our headlines, national borders, political squabbles, economic disputes would suddenly be cast in a stark new light. Faced with the overwhelming reality of a shared cosmic neighborhood with another intelligence, the concept of us versus them would be redefined on a planetary scale. Humanity would, for the first time, have a compelling, tangible reason to see itself as a single species, a single crew on a small, fragile planet. This could catalyze an unprecedented era of global cooperation as we pool our resources and intellect to better understand and perhaps one day communicate with our newfound neighbors. The very arts would be transformed. Our music, literature, and visual art would be infused with new symbols, new mythologies, and a new sense of cosmic scale, forever marked by the day we learned we were part of a much larger community. Yet, this new perspective would also come with a profound and unsettling responsibility. The zoo hypothesis we discussed earlier would take on a new, urgent relevance. If the Jovians are aware of us and have chosen not to interfere, their existence becomes a silent judgment on our own maturity. It would force us to look in the mirror and ask ourselves the most difficult questions. Are we a species worth communicating with? Have we overcome our self-destructive tendencies, our tribalisms, and our short-sighted exploitation of our own planet to a degree that would make us interesting or even acceptable to a truly advanced society? Their silent presence would be a constant, humbling challenge to grow up, to evolve not just technologically, but ethically and spiritually. The greatest implication of contact, therefore, may not be the technology we acquire or the science we learn, but the mirror it holds up to our own civilization, showing us both our staggering potential and the immense distance we have yet to travel. But beyond all the data, the theories, and the arguments, there is a final, essential step we must all take, one that requires no telescope, no advanced degree, only a willingness to look up and truly see. We must consciously, deliberately, and permanently change how we view that brilliant, steady point of light in our night sky. We have to make the leap from seeing Jupiter as merely a planet, a subject of study, to recognizing it as a world in the fullest, richest sense of the word. For our entire history, we have gazed upon its banded face and seen a beautiful, distant object, a giant ball of swirling gas governed by impersonal laws of physics. It is time to replace that image with something far more profound. The next time you find yourself under a clear, dark sky and you spot that unmistakable, non-twinkling jewel, I want you to pause. I want you to consciously reject the old view. Don't see a placid, striped marble. See a dynamic, churning biosphere. See a global ocean of atmosphere, thousands of miles deep, where colossal beings might drift on eternal winds. See a planet crackling with energy, its magnetic field alive with activity, a medium that could itself be the substrate for thought. See a civilization, not in the way we imagine cities and roads, but as a vast, interconnected consciousness woven into the very fabric of the storms. See a world with a past, a present, and a future, a history we cannot yet read, a culture we cannot yet comprehend, and mysteries that are waiting, not light years away, but right next door, for us to be curious enough to unravel them. This shift in perspective is not just poetic license, it is a critical tool for discovery. Our perception fundamentally shapes our questions. If we see only a gas ball, we ask only questions of physics and chemistry. How fast do the winds blow? What is the composition of the clouds? These are vital questions, but they are not the only ones. When we see a world, we open the door to entirely new lines of inquiry. We begin to ask about ecology, about communication, about society and technology. We start to look for the signatures of complexity that transcend simple natural processes. By granting Jupiter the status of a world, we give ourselves permission to ask the bigger, more daring questions that could ultimately lead to the greatest discovery in human history. It is the difference between a geologist studying a mountain and an anthropologist studying a city. Both are valid, but one is searching for signs of a mind. Now close your eyes for a moment and let this new vision crystallize. Picture Jupiter not as a distant dot, but from a vantage point just above its cloud tops. See the incredible, swirling tapestry of creams, oranges, and browns, not as passive paint on a sphere, but as the dynamic, living skin of an entire biosphere. Imagine diving down into those clouds through layers of mist and storm, into a realm of perpetual twilight where the very air is thick with possibility. Imagine the strange, slow chemistry of that environment giving rise to forms and functions we can scarcely imagine. Then pull your perspective back farther and farther until Jupiter is a single globe hanging in the blackness of space. See it as an entire system, the planet itself, its radiant belts of radiation, and its attending moons, all potentially connected by the invisible threads of a society that has learned to thrive there. This is not a fantasy, it is a possibility grounded in the very real, complex, and unexplained phenomena that our machines have already recorded. It is a reality waiting for our minds to catch up to the evidence. This is the true legacy of this mystery. It is an invitation to participate in a new kind of exploration, one that happens as much in the theater of the mind as it does in the vacuum of space. The greatest voyages of discovery begin not with a rocket launch, but with a thought. They begin when someone dares to look at something familiar and see it as something entirely new. So, the next time you stand under the canopy of the night, and your eyes are drawn to that bright, steady beacon, remember what you now know. Remember the roar of its radio voice, the puzzle of its persistent storms, the tantalizing hints of structure in its chaos. See it not as a distant wonder, but as a neighbor. See it not as a planet, but as a world. And in doing so, you take the first and most important step in the greatest adventure we may ever know. The day we finally reach out and discover that we have been living next door to another mind all along. From the roaring crackle of natural radio bursts to the faint, structured whispers hidden within, our journey to Jupiter has been one of expanding perspective. We began with a straightforward scientific marvel, the incredible power of the EO flux tube and the plasma physics that can create a planetary-scale radio station. But as we listened more carefully, we found threads of something more, anomalies that don't quite fit the established picture. The quasi-periodic patterns, the intricate modulations, the statistical fingerprints of organized complexity that seem to go beyond the capabilities of a mindless natural process. We've confronted the profound power of these signals, a raw energy output that rivals our sun in specific wavelengths, and we've asked a simple yet revolutionary question. If you needed to broadcast your presence across the cosmos, wouldn't you build a transmitter exactly this powerful? We've explored the unique nature of Jupiter itself, a world so vast, so energetically rich, and so fundamentally different from our own that it could harbor forms of life and intelligence we are only beginning to imagine, from colossal floaters grazing in the cloud decks to sentient whirlwinds of plasma thinking in the language of magnetic storms. And we've seen how this single, swirling world in our own backyard offers an elegant and breathtaking solution to some of our deepest cosmic puzzles, from the eerie silence of the Fermi paradox to the Drake equation's lonely estimates, turning the great quiet into a potential chorus of disguised life. The circumstantial case, while far from proven, is compelling. It's not built on a single, irrefutable piece of evidence, but on a convergence of fascinating clues that, when viewed together, paint a picture that is impossible to ignore. The patterns hint at a mind, the power suggests a purpose, the planet's unique environment provides the canvas, and the resolution of cosmic loneliness offers a profound and hopeful narrative. This isn't about discarding science, but about pushing it to its creative limits, about daring to ask if the most natural explanation might, in fact, be the most extraordinary one. We stand at a threshold where the line between established planetary science and the most thrilling frontier of astrobiology has become wonderfully, tantalizingly blurred. The static is no longer just static, it is a mystery, and the giant next door is no longer just a planet, it is a world waiting for us to finally understand its voice. This is where the story transforms from a passive observation into an active human endeavor. The next chapter in this grand mystery is not written yet. It will be written by the missions we fund, the telescopes we build, and the collective curiosity we choose to foster. The greatest discovery in human history, the confirmation that we are not alone in the universe, might not require a journey to a distant star. It might be waiting for us right next door, hidden in the chaotic beauty of Jupiter's storms, encoded in the radio whispers we are only just learning to decode. It demands that we keep looking, keep listening, and keep questioning. So the next time you see that bright, steady light in the night sky, I urge you to see it not as a distant point of light, but as a neighbor. Let it fill you with a sense of wonder and possibility. Let it remind you that the universe is far stranger and more wonderful than we have ever dared to dream. And let that wonder translate into support for the scientific exploration that will ultimately unveil the truth. Because the answer to one of humanity's oldest questions is likely hanging in the sky above us, not as a distant dream, but as a roaring, beautiful, and mysterious world, inviting us to finally come